Okay, so we're going to do an optimization problem using marginal analysis. So we're going to start out by using our inverse demand function, which is going to be given as P equals 20 minus Q. And then our revenues from that as a function of Q is simply number of units sold times the price sold, which is equal to 20Q minus Q squared. Then we're going to be given our cost curve, and our cost as a function of Q is equal to, again given, 10 plus 6Q. So then all we need to do is optimize. We want to find the optimal Q that will give us the greatest profit. And profit is given by revenue minus cost. So now we'll say profit, which is given as pi as a function of Q, is equal to 20Q minus Q squared minus, now put this in parentheses, 10 plus 6Q. So we have our revenue here and our cost here. Now we're going to use marginal analysis to find the optimum. So we want to find out where the change in profit is equal to 0. That's at that slope, when the slope is equal to 0, we know we've maximized it. So we're going to take the derivative of profit, change in profit, as we change our production. That's going to have two effects. It's going to affect our revenue this way. Derivative of 20Q is 20. The derivative of Q squared is 2Q. And it also affects our cost. Minus, derivative of 10 is 0. Derivative of 6Q is 6. Alright, so now we have our marginal revenue here and our marginal cost here. And we want this to be equal to 0. We want the slope of the profit function to be equal to 0. So we're at that top of the curve here. So just imagine your profit curve is looking like this. You want to find out this point right there. At that point, it's when the slope is equal to 0. All right? So go back here. We have 20 minus 2Q minus 6 equals 0. We're going to take 20 minus 6 equals 14. I'm going to take this minus 2, bring it over to the other side and make it 2Q. Divide both sides by 2, and we're given Q equals 7. We take this number here, plug it back into our inverse demand function. Inverse demand function was 20 minus Q. So that means that if we insert 7 equals Q into here, then P equals 20 minus 7, which equals 13. Now that we have all of our variables, we can calculate profits. Profits now equal 20 times 7 minus 7 squared minus 10 plus 6 times 7. And this becomes 140 minus 49 minus 52. And this is 39. So this is our profits. This is our price. And this is our quantity, or output. So if I go back up here to our profit, this is what the profit function would look like. This is 7. At this point right here, it's 39. And so now we've been able to optimize our profits using marginal analysis. Hope you enjoyed it.